What if scattered 3D fragments could be reconstructed with precision in a digital workspace, while every piece remained connected to its essential database record? This is the purpose of Assembly3D. Assembly3D allows you to import 3D fragments, inspect them from every angle, align them accurately, and gradually rebuild the original object in a controlled digital environment. At the same time, each fragment can remain linked to its object information, measurements, images, and database record. In this way, the reconstruction process becomes more than visual assembly. It becomes a structured documentation workflow. From scattered fragments to a complete, data-linked reconstruction, Assembly3D supports the full process from import to professional export. Why Assembly3D? Manual reconstruction of fragmented 3D objects can be slow, difficult to verify, and risky for fragile originals. In archaeological and conservation work, another problem often appears. Important information about each fragment may be scattered across notes, photographs, spreadsheets, and separate databases. This makes tracking, comparison, and interpretation more difficult. Assembly3D addresses this problem by providing a precise digital workspace where fragments can be imported, organized, inspected, aligned, reconstructed, and documented in one place. The application is especially useful for archaeological fragments, broken artifacts, conservation projects, research collections, and any workflow that requires accurate spatial control. It guides the user through the full reconstruction process, from creating a project, importing models, managing fragment data, aligning pieces, and exporting the final result. Create a new project. The workflow begins by creating a new project. A project acts as the main workspace for your reconstruction. It stores the fragments, the reconstruction progress, the object data, measurements, scale information, and export settings. To begin, click New Project or Create Project. Then enter the essential project information, such as the project name, a short description, and the surface type. Each surface type includes a brief explanation to help you choose the most suitable option for your object. Not every field has to be completed immediately. You can start with the essential information and add more details later. Once the required information is ready, click Create Project. Each project can contain multiple fragments, and each fragment can be linked to its own database information. This makes Assembly3D more than a 3D viewer. It becomes a structured environment for reconstruction, documentation, and research. Import 3D models. After creating the project, you can begin importing 3D models. Return to the workspace, click Fragments, and then choose Add Fragment. Each imported model is treated as an individual fragment. During this step, you can attach important information to the fragment, including the project name, object details, measurements, and mesh data. For the 3D model itself, click Upload 3D Mesh and select a supported file format. Supported formats may include OBJ, STL, PLY, GLB, or GLTF, depending on the enabled import pipeline. You can also upload a preview image for the fragment by clicking Upload 3D Preview Image. Some workflows may include additional import options. For example, Apply Transforms can bake the object's position, rotation, and scale into the mesh before import. Another option, Embed Textures in GLB, allows texture images to be packed inside the GLB file so they load correctly with the model. After entering the required information, click Create Fragment. Repeat this process until all required fragments have been added. At first, a new fragment may appear under the Unassigned section. After clicking Refresh, it should move into the selected project. This process allows Assembly3D to function not only as a 3D workspace, but also as an organized fragment database. Import data and manage settings. The toolbar provides additional tools for managing your data. You can import an Excel sheet containing object information, fragment data, and file paths for related images stored on your computer. You can also download an empty Excel template that follows the format required by the application. This is useful when you want to prepare project and fragment data before importing it into the system. The toolbar also allows you to create new database fields for your fragments and define their properties. You can add custom fields to the project itself and control project-level information. In the general project settings, you can check available storage space, synchronize data, and clear the local cache when needed. These tools help keep the reconstruction environment organized and scalable. Automatic scene placement. Once a model is imported, Assembly3D places it inside the 3D workspace. The application can center the object and normalize its initial position, making it ready for viewing and interaction. You can then open the desired project and begin working with the imported fragments. This automatic placement helps reduce setup time and allows you to move quickly into inspection and reconstruction. View and navigate the workspace. Inside the project, the imported fragments appear in an interactive 3D viewport. You can freely navigate the scene. You can orbit around the object, zoom in and out, and pan across the workspace. Navigation guidance is available in the lower left corner of the screen. This makes it easier to study surfaces, break edges, possible joins, and the spatial relationships between fragments. For reconstruction work, this stage is essential. Before aligning fragments, you need to understand their geometry, orientation, and possible contact zones. Select and inspect fragments. Each fragment in the workspace can be selected individually. You can select a fragment by clicking directly on it in the 3D scene, or by choosing it from the left side panel. Once selected, the fragment becomes active for editing and transformation. This allows you to isolate one object from the rest and work on it with precision. You can also select multiple fragments by holding the Control key while choosing several objects. When you double-click a fragment, a panel appears on the right side. This panel displays the connected object information and database record. From here, you can make fine adjustments using exact position and rotation values. You can also lock the fragment's position so it remains fixed, or remove it from the scene when needed. Selection is a critical part of the reconstruction workflow because each fragment often needs to be adjusted independently before it can be aligned with the others. Transform the model. After selecting a fragment, you can manipulate it using transformation tools. The Move tool allows you to reposition the fragment freely within the 3D workspace. This helps you test possible joins and adjust the fragment's placement relative to other pieces. The Rotate tool allows you to turn the fragment around the required axis. This is useful for matching broken edges, surfaces, and orientations more accurately. The Scale tool allows you to resize the fragment when necessary. This may be useful for correction, comparison, or maintaining consistency with the project scale. Together, these tools allow you to test the spatial relationship between fragments and gradually move toward a possible reconstruction. The transformation system is designed for both broad movement and very small controlled adjustments. In advanced workflows, uniform scaling can also be applied across all fragments when imported models need to be rescaled consistently. Align and reconstruct the object. The core purpose of Assembly3D is the digital reassembly of fragmented objects. Fragments can be brought together manually by moving and rotating them until they visually and spatially match. This process may involve edge-to-edge positioning, surface comparison, angle correction, contact zone testing, and repeated refinement. The goal is to gradually reconstruct the original object in virtual 3D space. Depending on the implementation, Assembly3D may also include helper tools such as snapping support, alignment guides, grouped movement, and transform locking. These features improve precision and reduce user error during reconstruction. Assembly3D also includes an option to clean your 3D model using the Clean Mesh tool. However, it is important to use this tool before positioning the objects on the canvas. Cleaning the mesh first helps avoid problems later during alignment and reconstruction. To begin, select the fragment you want to clean. Then click Clean Mesh. In the right-hand panel, choose the viewing mode that works best for your model. You can use X-ray view, wireframe view, or both, depending on what you need to see. Next, choose the cleaning mode. You can select unwanted geometry by clicking individual faces, selecting an island component, drawing a rectangle selection, or using the brush tool. After selecting the areas you want to remove, click Delete Selection. You can delete the selected parts after each cleaning step, or you can continue selecting all unwanted areas first and delete them at the end. You also have other options. You can click Hide Selection if you only want to hide the selected parts temporarily. Or you can choose Keep Only Selection if you want to keep the selected area and remove everything else. Which option you choose depends on your specific cleaning task. From the History panel, you can undo your previous actions or reset the cleaning process if needed. When you are satisfied with the result, click Save. Your cleaned fragment is now ready to return to the Assembly3D workspace for positioning, alignment, and reconstruction. From the right side panel, you can fine-tune the position more accurately, control the fragment's opacity, and adjust the layer order. As the reconstruction develops, the scene can be organized into a cleaner and more manageable structure. This is especially important for complex objects with many fragments. Once the reconstruction is complete, or once you reach a useful working stage, you can prepare the project for export. Assembly3D can export the reconstructed result as a 3D file for use in other software. This may include a single assembled object, grouped models, or the full workspace scene. Typical export formats may include OBJ, STL, GLB, GLTF, or PLY. These exports make the reconstruction useful for archiving, analysis, visualization, conservation, or 3D printing. Export 2D views and documentation images. In addition to 3D model export, Assembly3D can generate 2D documentation images from the reconstructed model. These outputs are especially useful for academic publication, reports, museum documentation, conservation records, and visual comparison sheets. You can export one view at a time, or create a combined sheet containing multiple views. This makes the export process not only technical, but also presentation ready. The result can be used in articles, catalogs, presentations, and institutional documentation with minimal external editing.